Algebra 2 Note 6.4 Part 1 on rational exponents. So let's first review negative exponents. Remember, we do not want to leave a negative exponent in our answer. So instead, what we can do is rewrite it as 1 over 5 to the positive second. So if it was in the denominator, we can move it to the numerator. If the negative exponent was in the numerator, we can move it to the denominator and simply get 1/25. Okay, one like the third one here, if the fractions to a negative exponent, we can right away just kind of trade both places with the 2 and the 3 and make it to the positive exponent. So then it becomes 3 to the third, 27, over 2 to the third is 8. So go ahead and pause your video, try the last two. All right, 10 to the negative fifth would be the same as 1 over 100,000. 1/2 to the negative fourth would be 2 to the fourth, or just 16. So how can we go from rational exponents back to radicals? Okay, what this is saying is that if you have a to the m over n, this fraction exponent, that's the same thing as the nth root of a to the m. So you're going to rely on this a bunch today and tomorrow. So go ahead and next week, I guess. Go ahead and take a look at that and think about how we could rewrite 4 to the 1/2. So 4 to the 1/2 would be the same thing as the index would be 2 and 4 to the first power. So again, since this is just a square root, we don't have to write the 2. We can just write square root of 4, which would just be 2. Okay, 27 to the 1/3, we can write the cubed root of 27 to the first, which is just going to be the cubed root of 27. What times what times what is 27? Should be 3. Okay. 10,000 to the 1/4, so that's the 4th root of 10,000 to the first power, which what times itself 4 times is 10,000? That would be 10 times 10 times 10 times 10. So the 4th root of 10,000 would just be 10. Okay, 12 to the 1/2. This would be the square root, 12 to the first power. So then we can rewrite just the square root of 12. But then we can break down square root of 12 to be square root of 4 times the square root of 3, or just 2 times the square root of 3. Okay, so we're kind of pulling in a lot of things that we've done before into this lesson, as well as a little bit of new stuff. All right, so let's jump down to this section. Write each expression in radical form. When the numerator is a number other than 1, remember in your fraction, that's going to be your exponent. So sometimes it might be easier to think of this as like 4 squared, and then that bottom number is going to go out front. So the cubed root of 4 squared. So what's 4 squared? That'd be 16. So the cubed root of 16, okay, that'd be in radical form. If we wanted to go further, which the directions didn't necessarily say it, but we could break up square root of 16, or cubed root of 16 as the cubed root of 8 and the cubed root of 2. So it'd be 2 times the cubed root of 2. Okay, I'm going to jump down and do this one down here. W to the negative 5/8. What we first need to do is rewrite that as a positive exponent. So remember, we just reviewed that at the beginning of class. We can make an exponent positive by moving it to the denominator, or vice versa. Okay, and then how do I put that in a radical? So we'll get 1 over the 8th root of w to the 5th. Okay, if you have a decimal, just change it to a fraction. So 0.2 would be the same thing as 2/10, which we could simplify to be 1/5. So then how would I write that? The 5th root of y. All right, go ahead and pause your video. Try these last 3. All right, so if we take a look at those, you have the 7th root of x to the 3rd, the 8th root of w to the 5th, and z to the negative 0.5. We could think of z to the negative 1/2, which would be the same as 1 over z to the 1/2, or 1 over the square root of z. All right, some more simplifying. So as long as your bases are the same, remember that we can add those exponents. So on this one, we can rewrite this as 8 to the 1/2 plus 1/2. So that's going to become 8 to the first power, or just 8. Okay, 3 to the 1/4, 3 to the 1/4 times, and then we want to try to get these bases the same. So instead of leaving it as 27, let's rewrite 27 as 3 to the 3rd power. So then we can get this one to be 3 to the 1/4 times 3 to the 3/4, and then we can now add those exponents. So just be 3. Okay, and then again, 100 and 1,000, try to think of that common base. So 100 we could write as 10 squared to the 1/5. The 1,000 we could write as 10 to the 3rd power to the 1/5. We can then multiply those exponents. Since it's a power to a power, we're going to multiply those. So 10 to the 2/5. Next one, multiply those, 10 to the 3/5. So we're going to get 10 to the 5/5 then when we add those, or just 10 to the 1, which is 10. All right, if we want to put these into exponential form, okay, remember, whatever this root is, that's going to be the number that goes on the bottom of your fraction. So 8 to the 5th stays how it is, and then that 2 is just on the bottom of the fraction, 8 to the 5/2. Okay, we can have this one written like this, or it's the same thing as the 5th root of b to the 3rd. It doesn't matter which one you do first, the 5th root or the 3rd power. So we can rewrite this one b to the 3rd, and then over 5. And finally, the last one would be x to the 4 over 3. Okay, x to the 4/3. All right, your assignment is on Go Formative, so you guys can get started with it.